this is the first, this is one of the important things is this whole process is multidisciplinary. And, you know, what a lot of people, when they approach data, is they think that my industry, my area, my thing, whether it's banking, medical, government, you know, institutions, manufacturing, that they're all different, but it's really all a root data problem. Now, the applications are going to vary based on what industry you're in. Your goals and your strategic objectives are going to vary, but the implications of big data and the implications of this cross the whole spectrum. And I want to set the stage that this is an interactive journey. You know, we will have some questions here at the end, and we want you to share not only here on this, but with the group, because we're setting up the stage and we want to know what you want to see for your problems, what you want to share, what you want to see, if there are areas that you want to tackle. And it's a multidisciplinary area across, you know, data, systems, security, and we've seen all too well in the last several days how security is a major area, you know, in operations. So this is a simplification. There's a lot of details to each of these, but you want to start again strategically. The big main steps are understanding the problem, really having good requirements. And I've seen where this is a challenge where we want to jump into things. Potential solutions, making sure that you really understand what your architecture and what your design is. Execution of it, which is one of the biggest areas is execution. And that's why so many areas and so many implementations end up being failures. And what, you know, defined by failures is they don't fulfill major intended either functionality or major intended things that they want it to accomplish. And then looking at the whole life cycle of post implementation, sustainability, scalability, you know, how you maintain security, and even an exit strategy. And so I'm sharing some from experience because they're not just anecdotes. These are statistically shown to be very big pitfalls and areas. And the first one is the execution first approach. I can't say how many times I've seen where the approach is what software can we get? You know, whether it's a custom software, Microsoft Dynamics, building a database, you know, pick whatever software package, you know, off there. And the first question they ask is, what can the software system do? Well, that's backwards because you haven't even really started with what you want to do and what you should be doing. You know, another common pitfall that I see is winging it. There's no process going through, addressing all the factors, really understanding what you need. And what this leads to is it leads to a trading of issues. And this has been one of the most common areas that I've seen where you really shift from one set of problems to a different set of problems because you think that the new thing is going to be a silver bullet that's going to help bring things together and solve what you need. So in that context, this is a a little bit of a process because I know a lot of institutions have to deal with things from procurement to, you know, dealing with multi-departments, dealing with institutional things. But it's important to note that these aren't just cliche terms. Agile, allows this process of individuals and interactions over process and tools, working with software and having comprehensive documentation, collaboration, negotiation, responding to change. And it's, iterative is another good term, where you're constantly doing continuous improvement. This isn't I figure it out, I know everything, I do that, and then I'm done. And that's rarely how any system or project or layout ever happens. It needs to be, because every time that you get things in place, then you get feedback and you realize that, oh, this isn't happening the way we want. Or you go through and you uncover new things because you have some things figured out. And then you say, oh, well, this uncovered some other needs. It uncovered some other issues. It uncovered other areas to address. And so it needs to be mixed in, where we have our framework of what we have to deal with a lot of times as institutions, but yet at the same time, being able to be flexible and being able to go through, which really produces a better end product in the end. So the first thing you want to start out with is your purpose and strategy. And again, that sounds very structured. It's like, oh yeah, of course you start with purpose, but you'd be surprised how many places don't. They start out, again, that pitfall. What can this stuff do? Show me the features. Well, strategically, what you want to find out is first what you are doing, understanding the current processes, understanding your data, understanding your security and your needs, your operations. And you want to really do this through a process that becomes, when I say formal, formal does not mean inflexible, back to the agile and iterative, but it does mean that you need to have a written, understood, gone through, vetted process that you're doing so that you can really reach good results with it. And then what am I trying to accomplish? Operations is obviously the big key. If you're working on big data and you're looking at something for marketing, or if you're working on big data and you're trying to find trends or analytics, or you're working on big data and you're trying to find AI or machine learning, you're learning images, like we've gone through, detecting cancer through MRI images. Whatever you're trying to do, you need to look at that and say, okay, what is it I'm trying to accomplish first? And then that becomes a guidepost and a benchmark for the things that you're trying to do. Do they align with that? And this is a really important part of it. Many times, and it's really interesting that we are actually going through a linear process, because there's a lot of steps through the classical traditional one. And yet at the same time, we really need to bring systems thinking into this, because systems thinking really helps us understand, because most challenges we face today are complex problems. It's much easier to solve problems, and here's why it happens, and I want you to understand this. It's much easier to solve problems if you can take that problem, segment it, silo it, look at it separate as an individual process. And that makes it really much easier for most humans and most systems and most things to solve. But that's not the world we live in. What we need to do is we need to start developing frameworks, architectures, algorithms, decision-making processes, safeguards, all these different things, where it almost becomes a framework, a logic condition, a decision-making process that then, no matter what types of things and inputs you feed into it, it will help you arrive at the correct results, rather than being fixed systems that are siloed and segmented, saying, well, we need to do this little process over here. So let's do this thing for it. Oh, and we have this other little process over here. We need to do this thing for it. And like the diagram shows here, there's a lot of interdependencies in systems thinking. So we need to balance this rigid process. We have, we have procurement, we have design, we have teams. Eventually we have to make decisions. We have to select vendors. We have to select softwares, and combining those and melding them with dynamic needs. So developing that framework and engine helps you make a decision-making process. And the other thing, back to the agile and iterative, and there's waterfall, there's all kinds of different methods, depending on which area you're in, from project management to the data side. But you build this mixture where you can have both the rigid processes that you need, and at the same time be very flexible and very dynamic within those processes. And that brings us to root cause analysis. When you talk about, like we were talking before, this framework, this engine that you build to help solve problems, most of the time what we're doing is people are identifying symptoms. And it's much harder. You would think that it's just a straightforward thing that you're like, oh yeah, that's a symptom, not the cause. But it's a little bit harder than that. You may say, hey, these reports are taking too long because our big data set is very large and trying to do it. Well, that may not be the actual, that may just be a symptom, or, we're not getting the data in a timely manner. That may be just a symptom. You may have other underlying things of your algorithms, what you're trying to sort through. Are you even getting good information? And when you don't go and dig down, always keep asking yourself, what's causing this? What's causing this? Because as you dig through those layers, you get to the root cause. And if you don't, what happens is you get to these silos, and there's a term I like to use, which is permutations, which permutations is just a nice simple term for exploding variations. Everybody knows how things grow, exponentially up. One of our great data talks for our speaker for the Experience IT talked a lot about this, where he even used the example of Schneider Electric, where they had all this inventory, and because they didn't have a framework that categorized it, that really organized it, that really brought it into a meaningful structure, they had 90,000 tables in their database with millions of columns. And when they re-architected it, it brought it down to a couple or a few hundred tables from 90,000, because there was an actual structure and framework around it. And so you've got to be very careful about really digging down to what you want to accomplish and digging down to these root causes, because otherwise you get an exploding number of variations that can happen, and then you have to start trying to chase each of those variations, and you get a very intractable solution and a very intractable problem. And that is where, like we said, the systems thinking, you've got to bring it down to an ecosystem. These things do not just work in a vacuum. They have to work with the rest of the organization. You've got to work with machines, interoperability, other softwares, other pieces of data, with humans, your operations, your people, your stakeholders, empowering those decisions, and really listening to the people on the front lines, because they have a much better idea of what's happening and the impact than a lot of times we really realize or give it credit for. Accessing the data. Do I have access to it? How do I access it? Where is it located? How do I get to it? Finance and accounting. They tend to be afterthoughts, but all these things of how they interact with your different areas. Vendors and suppliers, you have software systems, other people who are interacting with you, who need to use things, from purchasing and inventory and analytics that need to cross organizations. So that brings us down to, this is the formal part of having flexibility within it, which is making sure you really do go through requirements and really understand your architecture. You know, a lot of times we think we understand what those design requirements are because we have a very superficial look at it, but they often take much more thought and much more work. Um, and we need to go through that process. What are we doing now? What is currently happening? And then what do we need to be doing? There was an old story that I remember, and in engineering, and this was, someone was on a manufacturing line and he was being trained, and he said, why are we doing it this way? It's convoluted, it doesn't make any sense. And the other person said, well, this is the way I was trained to do it. So they went and asked the person that trained that person, and they didn't know. So they had the contact for a person who retired who had trained them, and they called him up and he said, oh, well, all they had were right-handed tools and I was left-handed. But that had continued and perpetuated through the whole process, because nobody actually stopped to think, you know, what they were actually doing. They just kept doing the same thing. And technologies have advanced quite a bit. There's a lot of new opportunities. There's a lot of ways to take advantage of things. And your requirements and your needs evolve over time. They're not static. You may have done things and they may have worked really well before, and you can learn from that, but you need to continue to evolve. Those who don't evolve end up really going by the wayside. And these need to be explicit when it comes to requirements. Now, notice I didn't say inflexible, and I want to keep hammering that home, is that explicit and formal do not mean rigid and inflexible. What they mean is that you really are going through the process of getting these and understanding them and making sure that it's communicated across the whole board, and that you have a formal understanding of them. Because ambiguity, unspecified requirements is where things go awry, especially when you're dealing with outside vendors and softwares. I've actually been on both sides of this, where if you're looking for what you want to communicate to a software vendor to help you, or what you want them to do, or if you're looking at evaluating stuff, if you've got to go through a formal procurement process. I've responded to many RFPs and many solicitations where you realize it's so hard to respond because it's so disjointed. There are conflicting requirements. There's a lot of unknowns, and that doesn't get you a good result, and it doesn't help the people that you're engaging with. And that's why this process is so important going through. And the strategy is the correct place to start, because this goes back to your purpose and what you're trying to accomplish. Because again, that becomes the engine, the framework where you evaluate everything against it. So formal design, you know, you can't get these solutions if you're not working towards achieving that goal. This is often needs to be both the strategic and the detailed going hand in hand, so that you can get it right. And realize that this goes back to that Agile part. There are many unknowns that can't be uncovered if you don't spend the time and energy, and that's cost, to go through these things. Then you can move on to, after you understand what you're trying to accomplish, after you understand your problem, then you start scoping it and start getting into, okay, how do I solve this problem? And when it comes to it, data provides you this root tool. And we talk about big data here in this group because it's such a critical part. But that data, and this is part of the big data, needs to be worked and needs to be translated. That data needs to translate into information. That information then needs to be translated into intelligence, things that you can make actionable decisions on. And when you go through, you've got to have a whole solutions architecture for this. This goes back to the multidisciplinary part. That system, that engine, that process. Because what happens is you realize you have a lot of data. You have huge amounts. Often people have data for the sake of having data, and that's not bad because it's data. But what's the condition of that data? Is that data siloed? What does it mean in correlation to your other data if you're trying to make, data sets and correlations? Is there duplication in that data? Can I even identify my data? And consolidation of that area rather than more siloing, making a systemic and a systems approach, because I'm going to quote, this is an article, but the article is based on a research paper that came out recently, that organizations with more than 1,000 people have on average 288 SaaS applications. That's a huge amount of siloing. That's a huge amount of segmentation of data. That's a huge amount of operations that are disjointed and disconnected. And so we need to look at things more from an enterprise approach and how we're going to get these so that we can actually make a functional organization that's going to work together and that's going to actually achieve the goals, that's going to reduce the cost, that's going to build that efficiency, that's going to deliver effective and great solutions to the customers. And so this is why I talk about this, because it's so important. It's so important to realize the state of where we are right now, that while so many of these SaaS solutions, and I'm not knocking any of them because there's some great ones out there, while so many of them have become available and people are like, oh yeah, I can just get this for this, I can get this for this. We're not taking a systemic approach, and we've found this SaaS sprawl to permeate everything that's going on. And it's really causing and wreaking havoc with the organizations, with the operations, and especially in terms of when it comes to data, because oftentimes the data is duplicated over and over again because they're siloed. You have the segmentation of this data, you have the access of this data, trying to pull that all together, because it becomes a huge undertaking and a huge task, and sometimes isn't possible, because then you also have to correlate the data. What does the data over here that may be a duplication, but what does that data mean, and how do I correlate it to the other pieces of data that I have over here so they're meaningful and they make sense? And you really have to look at, how do I work with this data? My choice of tools is really an important, target, whether this is platforms. And again, I advocate, or disparage none of them, but, you have things from, custom software. People build databases, they build software, they build things, they build algorithms so that you can tackle those. Those have their own challenges, the cost and expense, security, upkeep. You've got commercial off the shelf. Hey, I can go get, and forgive me, I'm going to be, coy. I can go get QuickBooks and do my accounting. You have your basic, commercial off the shelf, and there's some very powerful ones on there. And then you have kind of your semi-custom, like, call them the low code, arena, your Salesforce, your Microsoft Dynamics, your Oracle NetSuite. And again, I'm not making any, advocation or disparage for any of them, but that type of category. And then here's an interesting one. We've dealt with this where you have open source versus proprietary. You've got a company or a system or a custom thing. And if you're doing it, there's a lot of times open source. We had a major one with Apache here about a week and a half ago, I think. where there was a lot of compromise to a lot of systems because it's a very widely used open architecture library that's amazing, incredibly powerful library. But at the same time, that open source also opened up a lot of vulnerabilities, and a lot of people did get compromised. You've got to look at the licensing for those, the cost, support. If you use open source, where are you going to find support for it? If you need additional features or if you need things done with it, where do you go with that? And then, of course, you have the liability and security on that. And so there's a lot of important decisions to make about this. And then after you go through all that, which as if that wasn't enough, then you've got to actually execute. And people underestimate execution far too often, and the details of the execution when they're going through these other phases. You've got to migrate from the old system to the new system. How is that data going to be mapped? How is it going to be moved? How is it going to be transitioned? The data structures from the old to the new, the correlation of the meaning of that data, APIs, connections, migration, interoperability with other software systems that you currently use, documentation and design. And that's often, it seems like a very old school way of addressing things, but you need sustainability with it. You need to really understand and know how these systems are set up so that you can continue forward in the future, so that people, as they leave the organization, as they come back in, testing and cutover, plan to test and have a testing plan. Know sometimes expected results. You have to have metrics to test again. Here's how I expect the system to operate. Is it operating that way? What's the downtime for cutovers? Rollback plans if things don't work. Unfortunately, I watched, or I know of a company that went through and did a major implementation, and they tried to cut over half a dozen times, and things didn't go as planned. Things weren't working as planned, and they actually had to roll back to their own system. And I've seen many examples where people have gotten into situations where they haven't planned for that. They've done the cutovers, and they're really stuck in a position where they can't get back. And then they're really caught in the lurch because of that downtime. And customer communication. You have to work with people so that they know that this is happening, they know what's coming, they know what to expect. You would be surprised how much change absolutely is so challenging for people. I always use the analogy, you can take someone's 30-year-old beat up Toyota Corolla and give them a brand new Rolls Royce, and they'll complain that there's too many buttons, it's too shiny, it's too powerful. Like, just because it's change, even if it's the best thing in the world, people don't handle change as well as they should. That doesn't mean that change isn't good. That's not doesn't mean that we don't push that forward, but you have to handle it, and you have to understand that that's a reality with things. And then after you get through that implementation, you've got to think about what comes next. And this needs to be part of the plan, even from the very beginning. And that's one of them is sustainability. People, talent, and knowledge. Who's going to maintain and upgrade this? And that goes both internally and externally, because a lot of times we use vendors. What does that vendor support look afterwards? Have we even built that into the proposal and the contract or the budgeting that we need support after it's implemented? What happens if that vendor goes away? Again, I've seen many examples where I've watched vendors and institutions get in screaming matches, and I'm talking very unprofessionally with each other. Relationships don't always go Well, sometimes the vendor isn't around, years down the road. Different things happen. You got to prepare for that. Internal support. We often overlook this, but people who are in an organization, they're going to take other jobs. They're going to move up. They may take jobs with other companies. They're going to come and they're going to go. You've got to plan for that. How do I even find that help? Where are these experts to get this whole process started, to implement it, to architect it, and then after the support, the place to maintain it and continue that ongoing? And because what happens if they go away after the engagement? You end up with yourself finding yourself a very difficult scenario to maintain it. Some of these implementations, even if they're on platforms, can be very complex and very difficult to maintain. You don't just bring someone else in, drop them in and say, okay, here, maintain it, or do this upgrade for me. That's often not realistic. And then you get into production and uptime. What does that maintenance look like? The impacts of production and downtime. There's a notion that you're never going to be down, and that's not realistic. You've got to have these mitigation plans in place. What's your resilience? Do you have, plans when things go wrong? Do you have your system structured so they have a continuity of business? Do they have redundancy? Backups and recovery time. And I've seen this over and over again. I don't know the details, so I'm making a disclosure, but obviously it was in the news. We saw Bernalillo County got hacked, and we saw, APS got hacked. And I feel awful for them, and I understand what a challenging situation it is to protect the systems and where they're at. Well, there's a notion that it's like, oh, well, we just restore the backups and we're all good. Well, in their case, that's going to take weeks. And I've seen it, and I've personally been in that scenario where what you think is going to take minutes or even hours stretches into days. Those days stretch into weeks. And so, especially when you're dealing with big data, because typically there's a lot to restore. And if you have multi-systems or your whole network or these things, or depending on what happens, you may have a lot of things to get back in place. You may have to rebuild your whole network. You may have to set a whole lot of things back up, even though you restore from backups. And so this can be a very lengthy, very costly, very difficult process. Which brings us to one of the big multidisciplinary areas, security. You are the target. And I've been watching this very closely, that it's not just APS, it's not just Bernalillo County, it's not just the Facebook hack or anything. These are actually accelerating. There's more and more vulnerabilities being exploited. There's more and more attacks happening. There's more and more security holes, again, often in open source software, often in operating systems, often in manufacturers' devices. Credential stealing is one of the big areas that's happening with the security arena. And you have to realize, this is no longer the kid in the basement trying to hack your organization. These are drug cartels, multi-billion-dollar organizations. These are governments. This is organized crime. These are highly trained and highly sophisticated professionals, because it's a very lucrative endeavor. And so we're seeing such an acceleration of these because their ability, their tools, the sophistication, the talent that they're sourcing has accelerated exponentially. And you have to realize, when you're dealing with security, security is always layers. You always assume that some layer of your security is compromised. And that's the basic tenet when you're talking security. You always assume it, and you say, okay, if this is compromised, then they still have to get through this. And if that's compromised too, then they have to get through this. And if that's compromised, then they still have to get through this. Those layers, and back to that term permutations, is what creates a structure that can help defend your organization when it comes to security. They just had an interesting white paper that got released that they were allowed to white hat hack major companies, banks, institutions, and they had an average compromise time of 2 days to compromise these organizations. We're talking oil and gas, financial institutions, banking. We're talking, technology firms, government. We're talking across the board. The average was 2 days to compromise them. Their success rate was 100% to compromise these organizations. And when we talk compromise, like in the case of the banks, they explicitly said they could have drained the money from the banks. We're not talking they got into their websites or they could spoof some emails. We're talking full out compromise. And so this is a serious endeavor and a serious issue that we're facing in protecting this data. And that's from physical, user security. In that white paper, 73% of the compromise vectors were admin credentials. And what you have to remember is you can trust the person, but can you trust their credentials? I call it, in a way, the Edward Snowden effect. And again, I'm not making any claims as to that particular scenario. I'm just saying one person who had the access credentials, if it was him or it wasn't this in the case, but just giving the example, or if someone else had compromised his credentials, once they got in and they had that, they basically had the keys to the kingdom. So you've got to look at mitigation and response. How do I deal with that? Third-party vulnerabilities. There's a lot of things from, like I mentioned, open source systems, operating system that you can't even know about and you can't really protect against because they're not really your things. You're buying them from third parties. And so if there's vulnerabilities in there, then you're open and exposed. And it's important to know the different types. Compromise is the data stolen, denial of service, ransomware, and there's a whole slew of them out there. And sorry to keep on this section for a while, but it's become especially pertinent, I think, recently. And then the last one is, and we're talking about big data, this kind of comes to a very important linchpin: scalability. Scale is tough. When you're dealing with big data, you've got volume, throughput, you have, use, including, future projections and spikes. A lot of times your utilization or your access to your things don't come in a nice, steady, even stream. They come in massive usage spikes. And that ability to scale, how do I keep adding resources? What's my scalability on that? How can I handle these major spikes? The cost and time for that scaling. Can I scale up? Can I scale down when I don't need it? And in big data, that becomes an especially pertinent arena where you're collecting and storing data. The storage area. It's like, where do I store this? How do I collect it? How do I make sure that I capture all of this? Moving data can be a tremendous challenge. We talked about the backups, but if you need to move a big data set from point A to point B, that can be a challenge. It's not just like, oh, I sent a file and it transmitted. This could be massive transmissions that could take long periods of time. And we've talked about this in the past, and I know in the future we'll talk about instead of moving the data to the compute, we move the compute to the data, restoring that data. And the operations and compute power, when you're working on that data, what is it going to take to get that and work on it? And then, of course, we have the arena of distributed data, which encompasses all these problems of getting to the data, bringing that all together, where you're doing the compute, moving that data around, because distributed data has become a really important part of the big data arena. And last but not, we're going to come to this last wrap up of, these important things of this kind of formal but flexible process. A lot of organizations have to go through procurement, some type, whether it's a government and there's laws and mandates with it, or whether it's an institution, you have to make sure that you protect yourself financially, that people can't have cronyism, embezzlement, and different things. And you want to work through this process and understand that you can do, no matter what the terms are, no matter what you're doing, you can do requests for information. Back to, you want to have a full understanding before you even do it. What's out there? What do you suggest as solutions? What things can we solve? Having consultants come in and actually, work with your organization. And consultants can be both external and internal, or a combination of both, to really design this and pull it together. How do you structure these proposals when you're trying to engage with or evaluate different companies? Because again, how you do that is going to greatly affect the results of what you're going to get proposed to you and what you're going to get delivered. Using contract vehicles, again, they can be private sector ones. Typically that's a government entity thing. And especially when you're in government, what you can and cannot ask vendors. It's sometimes just people not realizing out of ignorance, but you can't work with a vendor on a design if they're going to be bidding on it. And so you have to be very careful about having these separations between preparing your RFP or preparing your proposal or preparing your solicitation, to be decoupled and segmented from people who are going to be responding to it. In the private sector, you may or may not have those requirements. It's probably a good practice anyway, because you can introduce bias and everything else in there anyway. And then the last part is the exit strategy. And I'll be wrapping up here because I know we're right at the time for this talk. Very often overlooked, planning for obsolescence. You're saying, I'm just planning to put this brand new system in place. And you're saying, plan for obsolescence, but we need to. Plan for a lifespan. How long do you expect this thing to be in operations? And again, this may not have to be a set in stone amount, but you've got to have some idea. What we're looking for the next thing here in the next 5 years. Maybe it's 6 years, maybe it's 8 years, maybe it's a decade. Do we think it's going to last that long? Because if we don't plan, we may get down the road and you realize that, you still have these very, very old systems that you're using from a decade, 15 years, 20 years ago. And I've seen that in many cases. Export capabilities. Understand now how you're going to get data out of your system for when you do move to the next step. And also that archive and long-term records. There's so many institutions who are paying software licensing or are having huge problems because they moved to a new system, they got all the new stuff set up, but they need, for compliance, for information, for access, for legal purposes, to have the retention of those old records. And they just have to keep the old system around because there's no way for them to really do anything other than just keeping it around so they can access that. So you see, it really comes to a holistic approach of how we get to data and how we take this systems approach with it so that we can tackle these problems and really get to good solutions. And that brings us to our conclusion, which is, setting the stage for the big data and AI peer group and this roadmap to 2022 is, we want to hear from you. I mean, what do you want to see? Are there any use cases or desires that apply to you that you want to see? Remember I mentioned at the very beginning, this is an interactive group. Do you want to sign up? Do you, give us, hey, we'd love to see things on this topic. Or maybe you want to give some presentations. and how we align and overview that. We are scheduling sessions to address these things that we want to solve, these real world problems that people are dealing with. And I want to mention this because this is often misunderstood. This isn't a group for myself and for others to just sit up here and come and talk and make a presentation. We're here to provide resources to everyone. There's a lot of knowledge and expertise in this group. And I want to give credit again that our big data peer group is made up of some phenomenal individuals. And reach out to us if you want a little bit of help in a discussion about, hey, I don't even know where to start, or, hey, I've got these problems, I don't know how to approach it or where to turn. We're here to be a resource to help as well, not just give presentations. And I'm going to include this, and we'll provide you the slides here for this presentation afterwards. Emily will have a chance to send these out. But here are links to our previous presentations. We've gone through AI, value addition, big data, examples like the New Mexico Water Data Initiative, communicating stuff to stakeholders, machine learning, great presentation by Chilse. The big data and AI peer group, roundtable discussion, our operations and scaling, trusted AI. How big is big data? What does that mean, big data? We have some tremendous experts and some tremendous talks, and this is going to continue here through this next year. So we hope that you continue to come, continue to join us. We hope that you invite others, invite your peers, invite people because we want to provide this as a value add, and we don't want it to just be a static presentation. We want engagement, we want involvement, and we want this to make a difference here for people, for organizations, and for New Mexico. So thank you very much for joining us. And I'd like to open it up for any questions or comments or things that we can engage here on a great discussion.
Thank you, Michael. This is really great. And as I posted there, this is very fascinating when you brought it down from 90K tables to a few hundred tables, or so many data elements to a few thousand data elements. So if you could share some more details about that success story, that would be great.
Yeah. When you're dealing with data, or really any approach to a system, what you need to have is an actual solutions and framework. And there's many terms you could use for it. Engine, framework, decision-making process, so that what it does is it allows you to take a bunch of inputs and understand and run it through this engine and then get the right outputs. Because if you try to solve things by just handling one piece at a time, rather than having an engine that always brings you from the inputs to an outputs of decision, you usually end up getting those permutations, and those permutations grow literally exponentially. That term is sometimes utilized too much, but it literally grows exponentially, and that's where you get this explosion. And it's intractable. It's intractable to keep trying to solve these problems. It's intractable to try and work through things from a data perspective, and it's intractable from a compute, a resource, the ability to solve these problems. And then you get much poorer results too, because you're trying to just band-aid and patch each little one, and those patches don't become very disjointed. And so when we talk about that, you realize that the permutations are a symptom. If you're getting, in fact, I always say this, there's a quote from Albert Einstein, make everything as simple as possible and no simpler. There comes a point where there's a certain complexity needed to understand or realize or solve problems. If you're starting to get this explosion of complexity, stop immediately in your tracks, because I can say with confidence and almost unequivocally, you're probably on the wrong path and you're heading down something that's going to cause you massive problems in the future. It's a telltale sign that you're not really understanding the problem, and you're not really getting something together that's going to be a good solution for you. And that goes in any factor, not just the data explosion, but if you're finding even in your operations and your steps, anytime you're starting to get those explosions of complexity, stop dead in your tracks. Go back and reevaluate and really start looking at things hard.
Very well said. My point was more, so this, when you talk about 90K tables, were they spread across the legacy, let's say my mainframes or variety of systems that they acquired through various companies, or having okay.
Yeah.
Because I worked on a system where we had 27,000 data elements, not the tables, but that itself, we have to break it out into each of the subject area and then crunch it. And then what we found, system of record was less. I mean, we do automation through Python, and then we put it into IBM data governance, but that took us significant amount of time, to go over.
Well, yeah, I mentioned early on in the talk about taking data, being able to translate that data to information, and then translating that information into intelligence. And I have to actually, we give Tony some credit for this as well too, because that was one of he's like, you should put that in, and he's amazing at that. Like I said, we have some incredible talent here in this group. And a lot of times when you're dealing with data, in artificial intelligence and machine learning, and even if you're not going to that level, even if you're just trying to use big data sets, like for marketing or anything else, data cleanup and data structuring often tends to be a big bulk of the work, long before you can even get to utilizing the data. And it becomes even more challenging when you have multiple data sets, because you have to have some way to correlate, those data pieces, where you may have information about person A in this data set, and how do I correlate it and know that it's the same person A in this data set? And how do I correlate and mesh that data, and what does it mean? And so there's a lot of things of how you work with data. You can utilize it, you can prepare it, you can get it in a form that you can utilize before you can even start that operating on the data, that really is critical.
Well, we're coming to the end of our time together, and so just wanted to see if there are any last questions or comments.
One more question for Mike. Mike, as you know, complexity on top of complexity equals a vulnerability. You had mentioned talking to the ransomware that just occurred at APS. Can you speak to that from some of the perspectives as it impacts us locally, not only as parents, but looking at the complexity of the system as it impacts the entire community?
Yeah, so when you're talking these types of compromises, again, there's different types. This one happened to be from, again, all I have is public knowledge. I have no, inside information on it, but it appears from what's been disclosed that it's a ransomware attack. And this comes down to a denial of service. And what happens is it took down the systems that are running their systems. And so in other words, it didn't affect their student information system per se. It was on, because that's the very nature of ransomware, it was on the operating systems in their network that run all these. And so it was a systemic cascading failure because their pipeline and their backbone was compromised. And now they have to not only get that backbone uncompromised and back up, but now they've got to get all these different pieces. One system in itself would be very difficult, but now you have that system, the interactions with the others, the configuration with the others. You obviously have a double challenge because you got compromised, which means your security measures were not sufficient enough in the first place. You can't just open it up the same way you had it before. Otherwise, you run the potential of getting compromised again. And so this goes back to that ecosystem where you have to realize that there's a lot of interdependencies. There's a lot of things that are complexities and cascading failures that can happen with these. And one compromise and one part of taking your systems down can have cascading impacts and failures, because now, since they can't take attendance and they can't know which students are there or not, then you can't have in-person classes, because that opens up a lot of security risks and a lot of problems and potential issues. There's a lot of custody battles that go on. It's just the reality of life. And you have to know which parent can and cannot pick up that kid, or if there's another guardian. And so if you lose access to that information, you know, a lot of things start to get impacted, and we often don't think about those. You know, we don't have a redundancy and resilience in place. We don't have a fallback plan. We don't have a restoration plan. We aren't understanding the complexities that are causing the issues and the cascading failures in the first place.
Thanks, Mike. Well said.
Thank you. Well, I know we've reached time here. I'd like to open up. Is there one? If there's one more question here, or anybody who has any information? Again, we want this to be interactive, and I'm going to reemphasize that. So please, it doesn't have to just be here. Reach out to us as well. Even if you have specific questions or you have scenarios that you're dealing with, there's a wealth of knowledge and experience here in this group, and we are happy and we are engaged, and we want to be there.
All right, well, it sounds like we're wrapping up. So thanks again, everybody, for coming. Thank you, Michael, for sharing. We really appreciate it. Stay tuned for the next talk in the series.
All right. Thank you, everyone.
Thanks.
you.
Have a great day.
Thank you very much. Thank you.
Bye.
Thank you. Thank you very much.
Thank you.